Question 11 is asking us to describe the single transformation that maps triangle A onto B. So as you can see, the shape remains the same. It's just that the shape B is an enlarged version of A. So if we compare the the lengths, if we compare this length, its corresponding length, just this, we can see that this has 2 units and this has 4 units, which means it has enlarged by a scale factor of of 2, and our center will be 0, 7. Why 0, 7? Because if we measure the distance from here, so this is 2, and if we take a second color over here, 4. So 2 over here, 4. So once again, the distance from the center is also increased by 2 units. Then part B is asking triangle A onto triangle C. So for triangle A onto triangle C, we can see that the size is same, but what happened is that its direction has changed. So as you can see that it's moved in this direction, which means that it has rotated clockwise at 90 degrees. So 90-degree rotation clockwise. This is for part B. And the center. Now, if we look at the center in this case would be the center in this case would be 3, 1. Reason being is that over here, if we count the distance, one from this point, and that corresponding point over here is this point. So 1, 2, 3, 4. 1, 2, 3, 4. It's equidistant, and the only thing that is changing is the direction. So if we take it over here and take that over here, 90 degree. That's what we're trying to prove, that there's a 90-degree rotation of at clockwise direction. Then question 12 is saying AO, OB, and OC are all radii. So that means this equals to this equals to this. AB equals to BC. Therefore, the triangle AOB is congruent to triangle COB. Draw a ring around the correct criterion for this statement. So they are similar because, as you can see, the lengths are similar. AO is already equal to OC and OB, and AB and BC are already given as equal. So SSS is the correct criterion for the similarity and congruency of these two triangles. Part B is saying that P, Q, R, and S are points in the circle, and T, Q, U is a tangent to the circle at Q. PR and SQ intersect at the center of the circle O, and PQ is parallel to SR. Calculate angle QSR. QSR is this triangle. We already know that when a tangent touches the radius of a circle, that angle is 90. Both these are 90. And when a sector is coming out of the diameter, this angle is also 90, and this is also 90, just by the way. So a lot of 90 degrees over here. So anyhow, if this is 90, that means, and this is 42, so that means this part over here is 48. And if this is 90, which means 90 minus 48 would also be 42 over here. So 42 degrees for this. Then it says angle PQS. PQS, this one. This would be 42 as well. Why? Because we have two parallel lines, and in parallel lines, alternate angles are equal. So if angle S is 42, angle QSR, then angle SQP would also be 42. Then third is POS. So for POS, just gonna write that over here. POS. For angle POS, that is this one. So we know that this is 42 and we know this is 42. And since all of these are coming from the center, so these lengths are all equal. Okay. So I'm gonna remove these extra things so it's like slightly easier to understand. Yeah. This is equal, this is equal, this is 48, this is 42. And so this would be also 48. This would be 42. And this is also 42. So we have to figure out this angle. So what we're going to do is, we know that we can easily calculate this angle by doing 180 minus 42 minus 42. This gives us angle POQ. So if we do 180 minus 42 minus 42, that is 96. And for POS, we will do 180 minus 96. That is 84. So 84 degrees is your angle POS. Question 15 is saying that Anya invests $6,000 in an account that pays compound interest at a rate of R% per year. At the end of 8 years, the account has earned $621.70 in interest. Calculate the value of R. So what we're going to do is, we're going to write it as 6,000 plus 621.70 equal to 6,000 times 1 plus R over 100 raised to the power of 8. Compound interest has a formula of your principal amount times 1 plus R over 100 raised to the power of time. Compound interest. Principal amount times 1 plus R over 100 to the power of time. So over here, we're adding 6,000 to 621.70 because like we're taking the final amount over here. So 621 was the interest amount. So we're going to add that to the principal amount because we want to see what the final amount is. So 6621.70 equals to 6,000 or 1 plus R over 100. So if we just rearrange it a bit, it's going to be 6,000 and minus 1 over minus 1 over here raised to the power of x. Actually, I'm going to do it step by step so that I don't get confused. Yeah. So first we divide 6,621.70 by 6,000, which gives us 1.10361 equals to 1 plus R over 100 to the power of 8. And I'm going to raise this to the power of 8 too. So 1.10361 equals to 1 plus R over 100. That gives us 1.0124, and then I'm going to subtract 1 from this and multiply that by 100. Gives us 1.24 is our interest rate. Yep, 1.24%. Okay, then question 14 is saying that y is directly proportional to the square of x plus 3. So y is directly proportional to the square of x plus 3, which means y equals to k times x plus 3 square. When we talk about direct proportion, that means both quantities are either increasing or decreasing. Hence, it's y equals to k times x plus 3 whole square. K is your constant of proportionality. Constant of proportionality. So we're going to first find the value of k by substituting x equals to 2 and y equals to 5. And that gives us 105 as the value of k. Then we put the value of k back into the equation that we made. So y equals to 105 times x plus 3 whole square. Now you substitute the second value of x into this equation to find the corresponding value of y, which is going to be 16 over 5. Then question 15 is saying a bag contains 5 green buttons, 2 blue buttons, and 6 white buttons. Maya takes 2 buttons at random from the bag without replacement. Calculate the probability that one button is green and the other button is not green. So for the probability of the button being green, that's going to be 5 over 5 plus 2 total buttons. I'm going to write that first. It's going to be 5 plus 2 plus 6, which is 13. So the denominator is going to be the total buttons. This is green. This is the total. Multiplied by the probability of it being a blue button now. So since it can be either a blue button or white button, so what I'm going to do is I'm going to combine the buttons and write that as 8 over here. And since the buttons are be taken without replacement, that means once we have taken a green button, so there's one less button in the total buttons. So the total now changes to 12. Or now let's say in the first case, we took a blue button. Now in the second case, I'm saying we're taking a white button. So 5 over 13 remains the same. 8 once again will be the total. And now it's going to be 12 again. So we're doing the same thing twice. But we don't know if whether it's the blue button in the first case or a blue button in the second case. So that's why we like combining the buttons, because they didn't put a restriction on that whether we're taking a blue button or a white button. In the first case, when you took a green button, there was a restriction. Hence, we just put 5 separately. So it's going to be 40 over 12 times 13, which is 156. 40 over 156. So 46 with 80 over 156. And we can definitely simplify that. 20 over 39. That is our probability.